In our previous video, we decided which technique to use for two very similar looking integrals. In this video, we are going to use integration by parts twice to integrate e to the x times cosine of 2x with respect to x. Stop the video here and choose u and dv. Right, did you make a choice? I chose u equals e to the x and dv equals cosine of 2x dx. You could rewrite this differently. Differentiating u with respect to x, we obtain e to the x. V is the antiderivative of cosine of 2x, so a half of sine 2x. Let me keep this out of the way. Replacing u, v, and du in the formula leads to another integral. Have we made a mistake? Not at all. We can now use by parts again. Let me show you. Choosing again u equals e to the x and dv equals sine of 2x dx, I'm going to go over this a bit quicker. Du equals e to the x dx and v equals minus a half of cosine of 2x. You can simply drag the constant a half outside the integral and replace u, v, and du into the formula again. Allow me to make some space. We expand the bracket. Remember that we are trying to find the integral of e to the x cosine of 2x. Now, pay attention. These two terms are like terms, so we can collect them to one side of the equation, the left one, for example. We end up with 5/4 of the integral that we are solving. The remaining terms stay the same. Multiplying both sides by 4/5, we end up with the result of integrating our function by parts twice. A good way to check this answer is by differentiating it. Speaking of which, I will leave you with this differentiation playlist that contains 5 videos. Happy learning!